This is Chapter 6, Lesson 4, Dilations. Let's go to the next page on the right, page 105. A dilation is an enlargement or a reduction of a figure, which means that the size changes, but the shape stays the same. One way to think about this is on a touch screen, like on a phone or a laptop or any other screen where you can touch, on a tablet, for example, you can make the size change, but the shape stays the same. So for example, these words here, if they were too small, you could make the screen bigger, and all of these letters would maintain the same shape. The size would be bigger, but it would be the same shape. Or vice versa, if this was too big, you could make it smaller. That's a reduction. And again, the size would change, but the shape of the letters would stay the same. So a dilation has a scale factor of k. If you have k larger than 1, there's an enlargement, or enlargement if k is greater than 1. If it is the same, it's exactly 1, and a reduction if it's less than 1, so between 0 and 1. Now let's think about how this makes sense. If you multiply a number by something larger than 1, your value would get bigger. That's an enlargement. If you multiply by exactly 1, it turns out to be the same number. And if you multiply by a value less than 1 but greater than 0, so still staying positive, like a fraction, 1/2, or any value between 0 and 1, there would be reduction or it would get smaller. So here is our notation. We're going to multiply the scale factor times each value in the ordered pair. So whatever your ordered pair is, the scale factor times the x value, the scale factor times the y value. And we already reviewed what happens if your scale factor is larger than 1, or between 0 and 1, or exactly 1. So here is an example. We have triangle ABC with these following vertices. We're going to find the image vertices with a scale factor of 4. So remember, the image is after the change. And if the scale factor is 4, that means k equals 4. So A prime, remember you're multiplying the scale factor times each value. 4 times 0 is 0. 4 times 1 is 4. And we can see that it does get larger when you multiply by a number greater than 1. So this is B prime. 8 times 4 is 32, and 2 times 4 is 8. And C prime, -6 times 4 is -24, and 4 times 4 is 16. Here are our new vertices with a scale factor of 4. And even if we're not graphing it, you should tell that you can graph these on a simple coordinate plane, but with values getting as large as 32 or -24, you're going to need a larger coordinate plane, because multiplying by a number greater than 1 is going to make an enlargement. Let's try another example. This time, example B, we are going to use the same exact vertices from the pre-image above here, and we're going to find the image vertices with a scale factor of 1/2. Now notice that the scale factor is between 0 and 1, less than 1, greater than 0, so that means we should be seeing a reduction. So remember, going back to the original pre-image values, 0 times 1/2, anything times 0 is 0. 1 times 1/2 is 1/2. For B prime, 8 times 1/2 is 4. And 2 times 1/2 is 1. And then finally, C prime, -6 from the pre-image times 1/2 is -3. And 4 times 1/2 is 2. We can see that if we were to graph the image vertices with a scale factor of 1/2, it does get smaller than our original pre-image vertices.